So time is a little of the essence here, so I'm going to just go ahead and start right now. So if you don't really know the format, what I do is I get 3 scenes from the show, and I find out what's wrong with them physically. And just so that you're all aware of how I'm going to do this, I have 3 scenes, I have 3 videos. The first 2 are a little bit more theoretical, and the third one is a lot of calculations and stuff in it. So bear with me with that. It gets a little confusing. So this is the first clip that I got, labeled the hoopla.
I call this one the hoopla!
And she was never seen again. So, sounds like a lot of hoopla to make over a little pony, right? Wrong. So, what's wrong with this scene? Hula hoops do not create lift to carry Apple Bloom into the air, and I'm aware that it's not actually a hula hoop in the show. It was described to be a ring from a barrel, and I know in the show they called them loop-de-hoops, but I'm just going to call them hula hoops because that's what I've called them for all my life, so I'm just going to call it that. Let me just move this a little closer. So I'm going to prove this wrong with the physics of how a helicopter works. So there's quite some obvious differences between a helicopter and a hula hoop. So this isn't a really good picture of the helicopter wings, but let's look at them side by side. If you were to like cut them open and you were to look at the at like how they're structured, you could see that a hula hoop would be round, and if it were spinning around in the air, it would the air would just kind of pass over and under it just normally. But something interesting happens when you have a wing. With the wing shape, you have air that passes over it that passes over a lot faster than the air at the bottom. So as a result, this faster airflow has a lower pressure than the air at the bottom. And so this higher pressure kind of pushes up towards the lower pressure. And so this force that pushes up from the bottom is known as lift. And that's essentially how any airplane or helicopter works. So in conclusion, since hula hoops are completely rounded, they cannot create lift, and Apple Bloom wouldn't have been able to fly. I'm sorry. Well, I'm going to explain how we can fix this scene. How can we make it so that Apple Bloom could have actually flown? So let's look at some humorous ways to do this. The first one, if we were to have propeller-equipped hula hoops, if you can imagine a hula hoop that has wings on it that spins really fast, that might work. I haven't tried this before, so I mean, like, it could work, possibly, but someone could try this at home. Well, maybe, I shouldn't say that, but yeah, that might work. Apple Bloom quickly turned to helium. Now, I know, if you remember my last one, I had mentioned that Applejack is made of dark matter, and so are the butterflies. So I figured like a little less mass would like counteract that. It could work in some theory. But I think that the third way to fix it is probably the most legitimate reason as to why this happened. Apple Bloom is actually a cartoon character that was animated to levitate while spinning a hula hoop on her tail. So if you can imagine, like, let's say Apple Bloom isn't real. Like, let's say if she was a cartoon and she was just like, they animated her to go up in the air as this hula hoop was spinning, that would probably be the best solution to this. So, yeah. Okay, so moving on to our second scene. I chose the pony tornado, and this video doesn't really show the pony tornado in action, but it kind of explains what it is and how it works. So I figured this would be a good scene to represent that. So let's play the second scene.
Every living thing depends on the life-giving nourishment of rainwater. And it is up to Cloudsdale to provide rain-filled clouds to every corner of Equestria. But how, one pony might ask, does Cloudsdale gather all this extra water? Tornado power! That's right, Pegasi-driven tornado power. A team of Pegasi combine their wing power to create a jumbo tornado, powerful enough to pull water out of the local reservoir and funnel it all the way up to Cloudsdale. Remember, Pegasi, your jumbo tornado must reach a minimum of 800 wing power to lift that water up to Cloudsdale.
Okay, so that's kind of essentially how a pony tornado works. So let's look at why this wouldn't really be correct. A tornado that is created by Pegasi can't really happen. And to prove this wrong, I'm going to use the physics of a tornado. So let's look at how an actual tornado is formed. So you have a supercell. It's over somewhere like in Kansas or like Oklahoma or something. And then you have these two airflows. One is cold, one is hot. And so you have this hot airflow that rises, and then you have this cold one that sinks. And it sort of creates this spinning effect that creates what is known as what I like to call a super fast spinny air thingy. But it's formally known as a rotating air column. But I like that name better. So then what happens is that because the supercell has this updraft, it pulls this air column up, and it kind of goes more like this to more like this. And this super fast spinny air thingy is pushed up by the supercell's updraft. And so now, instead of this air column being horizontal, it's now vertical. And once it touches down to the ground, that becomes a tornado. So you have this updraft pulling things up and spinning things around. And it kind of sucks for us, but apparently not for Ponyville because they kind of need it for the water. So let's look at how a pony tornado is formed. Ponies fly around in a circle really fast, and that's about it. There's no upward force to push this air up, and probably at the reservoir at the bottom, it would make a really epic hot tub, but it wouldn't lift. It would just spin around. So it wouldn't lift up in the air. And I would like to go off on a little tangent right here. Can we talk about why the episode is called Hurricane Fluttershy if there's a tornado? Because I would like to address this because like the weird thing about it too is that I don't know if you knew this, but hurricanes are like when they're named. I know that like it's the convenience of being named like Hurricane Fluttershy, but when they name them, they go in alphabetical order. So this would have been the 6th hurricane of the season. No ponies are talking about it. All the houses are fine. I thought that was kind of strange. There's no way that there's just a hurricane that just happened at the same time as this tornado. So I have a few episode suggestions for like the title. I like the title Twister Shy, and I thought that would be really awesome, right? You'd have like a Helen Hunt and a Bill Paxton pony, and they're like fighting like tornado mysteries, and they have like the little balls from Dorothy that are like flying up in the tornado. And then there's like the 10 people maybe in this room who are like, yeah, that's totally accurate because I saw Twister. Like, because I don't think a lot of people saw Twister. Rotating air column Fluttershy, that could be that would make a little bit more sense, but it would be a lot longer. So, but I know I'm going off topic. So let's just go to the conclusion. The ponies cannot create a tornado made of Pegasi that just spin around in a circle. And this results in no water being lifted and carried to Cloudsdale. So how can we fix this? Maybe if the ponies spin around in a circle but also in an upward direction, like if they spun, but then they also kind of went like this, that might work. Because, I haven't seen a tornado made from ponies flying around, but that would be a pretty cool sight to see, but I don't know if it would work or not. The Pegasi could simply create a tornado by moving clouds in the air around. I never got this, and I know that regardless that clouds require water, and that's the whole point of the tornado, to bring the water to make the clouds, they should have like a reservoir of water and then save that to make a supercell and then to make the air flows, and then it just makes a tornado anyway. Like, I figured that like this is kind of like the economics of ponies though. So like, but I'm not an economics major. Okay, so now this is my third scene. And again, bear with me because the explanation is going to get pretty long and it's kind of tedious and it might be kind of confusing, but here we go with it anyway.
Yes. This is definitely the right direction.
It feels like we're going in circles.
Well, that's impossible. Are you suggesting that I'm reading the map wrong?
So, as I called this scene the transporter because she just kind of appears behind Applejack. And so again, what's wrong with this is that Pinkie Pie just appears behind Applejack too quickly to follow physical law. And so what I'm going to do is use kinematics, angles, and a lot of assumptions that I know what I said before, but yeah, I'm just going to forget what I said earlier, just just don't remember that. Okay, so first let's look at Pinkie Pie's path. She walks around in a circle like this, and just to kind of explain the scene a little bit more, she's walking back and forth, and then she suddenly kind of pops up behind Applejack. And so what I'm going to question is if she was able to walk around this circle quick enough to appear behind Applejack. So this is calculations part 1. First, and by the way, I figured that the best way to find how to do this is to find, I need a scale of how big things are in the scene. So in order to find the size of the circle, I should find the size of Pinkie Pie and Applejack using real-life pony statistics. So according to Wikipedia, a small pony is at most 12.2 hands tall, or 1.3 meters. And so let's assume that this is how tall Pinkie Pie and Applejack are. So you have, I drew this little scale here for 1.3 meters, and then I drew this circle here to represent the circle that she's walking around. Now, it's hard to tell where the center of the circle is, but I figured that this is kind of the best way to see where the circle is, because the camera's kind of at an angle, so it's a little hard to tell, but I did the best that I could with drawing these lines. And then I drew these 2 lines going to Pinkie Pie and Applejack, and they make kind of 2 slices out of the circle, or these 2 little slices. And then I drew these 2 red lines. These represent the 6 slices on the top of the circle. Let's just say that they're equal angle. I know I'm assuming that they're equal angle, but let's just pretend for a second. So if there's 6 slices in the circle, the semicircle that's 180 degrees, each slice has 30 degrees. And so the angle of the slice of Pinkie Pie's circle between Pinkie Pie and Applejack is 60 degrees because there's 2 slices. And also, this is a big assumption, but let's just say that the distance between Pinkie Pie and Applejack along the circle is 1.3 meters. I did this by rotating that scale of one of the 2 black bars, and I figured give length of the curvature of the circle. Let's just say it's 1.3 meters. That's just easier. So I used this formula. Theta is equal to segment over radius, and so 60 degrees would be the angle in theta, or in fancy math terms, is pi over 3 radians, and the S is 1.3 meters. So we could find the radius with this formula, which I found 1.24 meters. Using this radius, we can find the circumference of the circle, which is 7.79 meters, and the circumference is the distance Pinkie Pie walked around. However, she disappeared from the right and reappears on the left. And so, timing the speed that she was out of view, there was the portion of the circle that she walked on that wasn't timed. So, the part that the actual scene is looking at, where she's walking back and forth, that's part of the circle that she's not walking on, so I'm not accounting for that. So, that little part of the circle was that 1.3 meter segment. Again, that's kind of an assumption, but let's go with it. So, I got the circumference, took away the segment, and I got a distance of 6.49 meters. Now, let's remember this distance of 6.49 meters a little later. That's going to come up, but we're going to enter part 2 of the calculation, so continue to bear with me. Before I use this distance to find the velocity that Pinkie Pie traveled, because again, like distance over time is velocity, I wanted to account for her possible acceleration. So according to a totally reliable web source, a thoroughbred horse can accelerate up to 13 meters per second. Again, it's probably reliable, so let's just trust this. So this is how fast that she could accelerate. And I recorded how long Pinkie Pie walked in the frame of view before she transported, like when she's just kind of walking back and forth slowly. So that was a distance of 1.3 meters over the time that I recorded of that scene, which was 2.04 seconds. She has a velocity of 0.637 meters per second. And I also recorded the amount of time it took for Pinkie Pie to exit the frame and to reappear on the other side for her transportation. That was 0.542 seconds. So I used these values, and I found a kinematic equation to find the final velocity. Okay, so let's say that she's going at this velocity. She accelerates at 13 meters per second for a total time of 0.542 seconds. And her final velocity would have been 7.683 meters per second. So what does this all mean? You might be thinking that. Okay, so let's say if Pinkie Pie were able to accelerate as fast as the fastest racing horse, by the end of the 0.542 seconds, she would have only gotten to a maximum speed of 7.683 meters per second. So let's use one more kinematic equation. This is the last one, I swear. Suppose Pinkie Pie were traveling at this speed for that entire amount of time. Let's just pretend that she was. Using this formula again, I found that if she were going that speed for that amount of time, she could have only covered 4.164 meters. So finally we can conclude that Pinkie Pie accelerating even as fast as possible, even by a racing horse, would have only made a distance of 4.164 meters, which is actually a large overstatement. However, the distance she walked around the circle would have had to have been, remember that distance before, 6.49 meters. So that's impossible. So therefore, there's no way that Pinkie Pie could have walked around that distance using a means of without using a means of transportation that is in our realm of understanding, if that makes sense. Okay. Well, what if she was? That could be in here. How to fix this? How could we fix this scene? Because I really would like to see Pinkie Pie do that. So how can we make this scene make sense? Pinkie Pie could be a Time Lord. She could have stopped time and just kind of gone. What? This is like the second to last slide. Okay. Okay, I'm running out of time, so let's try to go through this really fast. Okay, so Pinkie Pie could be a robot that could accelerate faster than her inferior biological counterpart. There are two Pinkie Pies, maybe. Pinkie Pie's made of antimatter. She's right next to Applejack, who's made of dark matter. So, like, there need to be this counterbalance in the universe or something. Wormholes? Out of anywhere that she could have transported to in the universe, it would have been at the, right there, right behind Applejack. Okay, so this is my overall conclusion. My Little Pony Friendship is Magic is still full of physical lawbreakers. Apple Bloom can't fly with a hula hoop, Pegasi cannot make tornadoes that are actually called hurricanes, and Pinkie Pie cannot walk around big circles in little time. So, that's it. I hope you enjoy the rest of Equestria LA, and if you have any questions, I know it said I was supposed to answer questions. I'm probably just going to be around, just walking around here. So I'll be right out there, and if you want to ask me anything, I'll answer them. So.